Hey YouTube, let me start this video by saying building your own CNC doesn't automatically make you a machinist. That being said, it's been a while since I've talked in depth about the CNC. So now is a good time to highlight some of the issues that can arise with the DIY CNC. Pretty much since I built the CNC, I've run the spindle at the same speed. Recently I've lowered the VFD frequency in an attempt to get it close to the right feeds and speeds. Here I'm measuring the spindle speed in an attempt to make sure it has enough torque to cut at lower RPMs. The first mistake is not really a DIY related mistake as much as it is a rookie one. Because I don't have real machinist experience, on these first lot of holes I'm having to play with the speeds on the fly. I started with a plunge rate of 100mm per minute and a feed rate of 500mm per minute, which was still a little low for the amount of flutes, spindle RPM and material I'm using. By the time I was happy with the sound of it cutting, I'd reduced that initial setting to 40%, or 40mm per minute for the plunge and 200mm for the feed. While I can punch into a website numbers to get ideal feeds and speeds, that doesn't necessarily mean the CNC or the cutters are going to support them. Being DIY means nothing is proven, and there is no one that has gone there before me to give me examples of what's possible. So traditionally I've been extremely conservative to the point of a shortened tool life. Coming up, we have a classic example of what happens when you don't pay attention. In our household we have a saying, if you don't pay attention, you pay with pain. And this is exactly one of those situations. Using a large spill board, it's hard to clamp down one side of the job. I don't pay enough attention here, and the two pieces of metal that I have holding down the job get stuck under the Z gantry. In an attempt to get the Z axis off the metal, I make my next unforeseen mistake. I failed to check the Z axis height before releasing it. The Z axis height was a couple of millimeters below the surface level at the time, and as a result, once freed, the cutter could dig into the job. Fortunately, this was not a serious problem, as I was yet to machine that surface area down. But what I did notice was a crack in the Z-axis bracket. I don't think this was caused by this incident, as it would push the Z-axis up. I think this is due to a past mistake of being slack and not fitting limit switches and bottoming them out to travel. This gouge does not present a serious problem, since it was only going to be machined away in a later toolpath operation. The rest of the holes were finished without any additional issues. I continued to monitor the speed just to check to see if the cutter was getting blunt or if it was struggling to maintain the appropriate revolutions per minute. The cutter was showing no appreciable signs of wear. The next mistake showed up when I tried to cut the centre hole. Because the spill board got wet numerous times cutting the steel alternator plate, this has caused some swelling in the MDF, leading to the aluminium not sitting very flat. The deck itself is very level with probably 1/4 of a millimetre variation, but the spill board had over 1 millimetre of variation, turning what should have been a 1/2 millimetre cut into a 1.8 millimetre cut. Clearly the cutter didn't like this, but I managed to stop it before the cutter broke. Again, this gouge wasn't a concern because of the future pocketing operation that was coming up, but as you can see, when the Z-axis height was reset and it was cutting just 1/2 millimetre of depth, the cutter had no problems whatsoever. I paused the operation for a moment just to ensure that the hole was central. This cut is not a mistake, this is the lead in for the next operation. Sometimes lead in and lead out is more problems than it's worth. In this particular case I knew that I was going to be cutting over the top of it, so it didn't concern me. It's getting a bit dark and hard to see, but the top left hand corner wasn't cutting due to the warpage. When I was doing holes it wasn't really a problem, but now that I was trying to mill a flat area, something had to be done about it. I took most of it out by packing one corner with a razor blade and a piece of plastic under another. This morning I decided I wanted to put 3mm holes in between the larger 6mm holes. I must have drilled this first lot of holes 4 times trying to work out why it wasn't cutting properly. I kept resetting the Z height, thinking that the cutter must be slipping in the spindle. I took the cutter out several times and looked at it before I finally worked out what was going on. Remember yesterday I said through slackness I never got around to fitting the limit switches. Well, the reason it wouldn't go down any further was because the bearing carriage was bottomed out on the Z-axis. It is the numerous times I've done this over the years that has more than likely caused the crack. Once I worked out what was going on, I stuck the cutter out a little bit further and it blew through the holes, which leads me to my next mistake. Yesterday it took probably 2.5 hours to drill all of the 6.2mm holes. Today it took me about 15 minutes to drill all of the 3mm holes. Why? Because yesterday I was trying to do a helix cut on the holes. Today I just did a plain drilling operation on the holes. As a rookie machinist, wrong tool paths probably caused me the most issues and the most amount of wasted time. The 3mm cutter drilled the 6 mounting holes in the 4mm alley with no problems, despite my fear that the fixed 500mm per minute plunge rate was going to break the 3mm cutter. Where I did run into problems and break the cutter was when I tried to cut the piece out. Remember yesterday how I nearly broke the 6mm cutter because I didn't reset the Z height? Well, it seems like that important piece of information slipped out of my head while I was sleeping, because that is what broke the 3mm cutter. I'm not used to the material not being flat, and it's causing me to make really stupid mistakes. So before I retried cutting it out, I went to all 4 corners looking for the highest one. Funny how smoothly things cut when you aren't trying to do a nearly 2mm cut with a 3mm cutter. In the photos at the end, you will see some circular marks where the cutout discs have spun around. If this was a showpiece, a drill instead of an end mill would have produced a much better result, as those round discs got stuck under the aluminium and contributed to my levelling issues. While I made mistake after mistake like a complete noob, majority of my stuff-ups were not visible in the end product. So now this bit is ready to be bolted onto the mower engine. That's it for this video. Thanks for watching. It's been a long one, but if you stuck it out to the end, I appreciate you making the effort to watch it. I'll catch you on the next one. Bye for now.